Let's see, what other plots did we want to make? Well, we have that column of the distance in furlongs, and I remember I split that into 2 parts because I don't really need the f, but I do need to turn this into a number so that I can calculate the length of the race in miles, and then we can do some math to find out the speed. So to do that, why don't we make a new column called furlongs? We'll say df, remember square braces, and the name of the column is how we address a column, and the name of my new column will be furlongs. Since the other columns are capitalized, I'll stick with the pattern, but that's just stylistic. This will be df of distance, which is called dist. Remember, to split it, we have to make sure that it's a string. Dot split is how we split. And what's our split character here between the 12 and the f, or the 10 and the f? It's a space. So we're going to have a single space in quotation marks. That tells us the split character. And remember, we need expand equals true, which will cause that to fill the full column after doing the split. I don't care about the f, so I have elements 0 and 1. I want only element 0 here. Executing this and then typing df again, we should see a new column called furlongs, which is listing 12s at the beginning. Notice it doesn't show us the whole data set by default because that's just a lot to look at, but it shows the beginning and the end, shows the first 5 rows and the last 5 rows. You might ask, why does it go only up to 4? Well, the first row, the 0th row, is just the header row. It's the header plus 4 data rows and then the last 5 rows. If I wanted to look at the first 10 rows, I could say df of 1:10, say 0:10, and notice it shows me just the header up to row 9. So that's a way to specify. If I put numbers in here, I'm specifying rows, and when I put in those names of the columns, I am specifying the column. So we have our furlongs now. We'd like a new column called miles. Remember, miles are furlongs divided by 8, since there are 8 furlongs in a mile. So we will say df of miles equals df of furlongs. I think it never hurts to copy paste. It saves you making typos. And remember, those data were strings so that we could split them, so we need to say as type float divided by 8. Let's check that this had the result we expect it to have. I see that the earliest races are 1.5 miles and the latest are 1.25 miles. That's exactly what we want. When you get in the habit of doing this, you don't have to type df all the time and check what happened, but it's kind of nice now to be able to check that for the expected behavior. So now that we have the race time in seconds and the length of the race in miles, in our miles column, we can define one more column that will record the speed. To do that, we're just going to divide one column by the other. So let's say df of speed, which will be in miles per hour. Don't forget the quotation marks there for the name, will equal df of miles divided by df of seconds. Hopefully you're saying now, that'll give you miles per second, and that's not what we want. That's good. Make sure that our seconds are an integer, a float, and we're dividing the number of miles by the number of hours. So hours is the seconds divided by 3,600, since there are 60 seconds per minute, 60 minutes per hour, so 60 squared is 3,600. And what mistake did I make here? Remember, to be consistent, I was capitalizing everything, so that looks good. And now to make a scatter plot, the command for scatterplot is just plot, so we can say plt.plot. Plot is part of the Matplotlib pyplot module. We need the plt. And the syntax here is to specify the x value and then the y value, just like the help file is telling me here. So my x value will be df of year, and my y value will be df of speed. I would like blue dots so that it looks like my plot in Google Sheets. Let's see how it looks. That is exactly what is expected. Remember, if we wanted to add the grid, we could have plt.grid here, empty parentheses, and that lets us guide our eye a little bit to judge particular data points. Now here's something powerful we can do with Pandas that I can't do easily with Google Sheets. I'd like to pick a particular horse that I know. I think maybe the most famous horse out of this whole collection is Secretariat, and I'm guessing that that's the horse with the top speed here. And since I know that that was the Kentucky Derby of 1973, that looks about right. But just to be sure, let's see how we can find out. I can make a number, I'll call it I, and say I equals dataframe.loc. So we're specifying a location in the data frame. This needs to go in square braces, and inside those square braces we need a condition that's going to be true. So what I'm going to say is df of winner equals. Notice we've been using equals quite a bit here. In Python, a single equals means assignment of a value. So it says what we have on the right is being assigned to the value on the left. If I want to test for equality, I need a double equal sign, and if the test turns out to be true, I'll get a value of true. If it turns out to be false, I will get a value of false. So we'll say secretariat.index, and if I type I now, I can see that this is 98, the 98th value. Copying this back to our previous command here, back when we were still making the plot, I can put that command right before my plot, and now I could say plt.plot of the same things, but put in a second set of parentheses here to specify the row of the column that I'm plotting. And let's make Secretariat red. Checking that, I can now see that I have all the data points, but that point, I was correct, it's the one I thought it was, is the fastest time and we've plotted it red. It's also nice that I can just copy syntax here, so I'm doing a Control-C now to get a whole additional plot. If I wanted not year versus speed, but year versus seconds, remember that the first argument is the x-axis and the second is the y-axis. And if we wanted, say, squares instead, I could use SO instead of, I could use BS instead of B lowercase o. Making that plot, we can see the familiar plot that we made already in Google Sheets. Remember, I can add the grid. We could also make Secretariat red in that plot as well. Just copy these lines. Come down to our next block of code in the notebook here and change this speed to seconds again. And there we have, not surprisingly, the fastest speed is the shortest time. So those are some examples of how to use the Pandas library to make the same plots that we made in Google Sheets. We have the histogram, we have the scatterplot of speed versus time, and the scatterplot of speed versus year, and time versus year. So I hope that's helpful. Please let me know if you have any questions.